So first I just wanted to show you, so we have our first test next Thursday, so in a week. Come on. So on your Canvas page, if you go to, come on, if you go to view all pages and you scroll down to review for exam 1, it's number 9. There's our exam review. So that is going to be something that you'll get points for. So this will be like extra credit for your test. So make sure that you, where to go? Make sure that you complete that. And it also will help you because if you're comfortable with anything on the review, you'll be fine on the test. Okay, so just make sure that you're very comfortable with, I don't know why this isn't popping up. There we go. Make sure you're comfortable for the test. So that's what it looks like. So obviously you'll have to do it on a separate sheet of paper on some of them, but at least it'll give you an idea of what's going to be on the test. Okay, so that is under pages. So you can, and you can print it if you want to. If you want to print it, you can, or you can just look at it and do it while it's there. The big key is make sure you hit view all pages, otherwise you won't find it. And don't go to files. Files will drive you nuts because it's everything that ever existed in my class. So, okay, so we've gone through the definition of a derivative, right? We've gone through the difference quotient, so you're going to have to kind of play catch up a little bit from what we worked on. Right on time. So Nicholas, I was just saying that on our Canvas page, under pages, view all pages, there's a review for our first test. Okay, and it is for a grade, so it's part of your homework grade. So that's where your review will be. So you can either print it and work it out, or you can just look at it online and then do it on a separate sheet of paper. So however you want to do it. Okay, so just a quick, and again, I give you all of these formulas. You don't have to memorize them. You don't have to write them down. They're just formulas that I give you. So the definition of the derivative is this. You've worked through quite a few of them. You know, you're feeling comfortable with them. I know we'll have to work on them with you a little bit. So what we're going to do tonight is we're going to now transition. Okay, so have you guys taken calculus at all? No? Okay. So everybody is on the same playing field now. Okay? All of your algebra skills are up to par. That's all you need. Now you're learning something new. Okay, so this is not something that some of you have seen before and some of you haven't. We're all on the same playing field, okay? So stop me. If there's something that you're not understanding, stop me and let's talk about it. Because if you have a question, maybe Joanna does too. So don't feel like, you're messing up the class or whatever. So here's what I'm going to do. I'm going to write out some derivatives, okay? The first way I write it out, I'm getting it through definition of the derivative, okay? Then I'm going to do I'm going to do the exact same function, finding the derivative in the new way. And I want to see if you guys can pick up the pattern, all right? It's a pattern, and it works every single time. Now, I could go through and show you why using definition of the derivative that it works every single time. I don't think we have time for that. But I'm going to show you one, and then I'm going to show you what it looks like, and then I want to see if you guys can come up with the pattern. Because if you guys can come up with the pattern, you don't have to memorize it, right? It's just an automatic, oh, this is what you do. So here we go. So our function is, we'll do the one that we did the other night, right? This is the one we did, right? Is that the right one? We did it twice, I think. It was on that last worksheet that we did, which remind me and I'll get it to you. So using the definition of the derivative, I'm going to go ahead and take some shortcuts. So 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3 minus 2x squared plus 5x minus 3 all over h. Okay, all looks really familiar, right? So just watch. You don't have to write this down. Just watch. I cross out my 2x squareds, cross out my 5x, cross out my 3's, and I end up with h times 4x plus 2h minus 5 all over h. I cancel my h's. The limit as h goes to 0, what does my limit become? 4x minus 5. Okay? So that's how we found the limit using the definition of the derivative. We started with this. We ended with this. Okay? I'm going to do another one. I'm not going to go through the whole process, though. I'm just going to give you the function and the derivative, function, derivative. You see if you can come up with it. All right, here we go. Here's a function. So the derivative is 18x squared plus 8x minus 3. Here's another function. So you don't have to write any of this down. I just want you to compare the two and see if you can come up with a pattern. And then I'm going to do one more. I'm going to do a big one. Okay, so that last one might, because it's so obvious, I mean, it's so exaggerated, you might be able to pick it up. What do you think?
You take the exponent times the constant and then subtract the exponent. So it's like for 6x cubed, 3 times 6 is 18, x squared, and then you take 2 times 4 and you get 8x, and then minus 3, because that's a 3x to the first. So it's 1 times negative 3, and then you can do the same thing for the next one and the next one.
Okay, so your theory, does it work for every single one? Do you guys see it? Do you agree, Casey? Does it work for every single one?
Does it?
That's what I'm asking. Do you agree that that scenario or that theory works? So his theory says he's taking the exponent and he's multiplying. And then what are you doing to get to here? You take one away. Okay? Now, what happens here? How did it go from negative 3x to just negative 3? Okay? So go back to the minus 3x. So does that theory still work, though? And how? How does it still work? Because he's right. He's absolutely right.
What do you mean, 3x?
Right here. So how did we go using that theory? How did he go from here to here?
You multiply it by the exponent on top, which is the first power.
Okay.
And then it's still negative because it's negative.
Okay, but what happened to the x? Everything else still had an x in it.
Just go down an x.
You drop an x. I'm sure there's like
I
a
don't know why it
mathematical
happened.
term. I'm sure there's like a mathematical term for it, but in my head it's just you drop an x.
Okay, so here's what it is.
Staircase.
It's,
Push it down.
you push it away. Here's what it is. Look, and you're absolutely right. You multiply, and then you subtract 1. Okay? You multiply, and then you subtract 1. So if that theory,
X, you don't subtract.
I'm subtracting one exponent.
Yeah.
Just one of the exponents, right? So let's see if the theory stands. If I multiply, I get negative 3, but then when I subtract 1, what do I get?
So 1 is 0 because it's an exponent. So you get a 1, so it's 3 times 1.
Yes. So this becomes x to the 0 power, which is 1. Negative 3 times 1 is negative 3. So that's why the x just drops off.
What is the negative exponent?
It's the same rule, okay? And that's what's cool about this. So here,
Do you go up or do you go like, if it's x to the negative 1, is it x to the negative
well, we'll find out. Well, fine, let me give you the rule. Let me give you the actual rule. But you did see it. That's exactly what it is. It's you multiply and subtract 1. Multiply, subtract 1. Multiply, subtract 1. Now, it's a pattern that works every single time. If you don't trust it, you can always go back to the definition of derivative. Be my guest, right? But good luck doing something like this, right? Could you imagine x plus h to the 100th power? What a nightmare that would be, right? So the rule does stand. You drop this and multiply. That's where I get my 40,000. And then I subtract 1. I drop this and multiply and then subtract 1. Okay? So that is called the power rule. So this is called the power rule. So I'm gonna give it to you in a very general way. Okay, so power rule for derivatives. So, all right, here we go. So here's our function. So here's our regular function. So it's nx to the a. Okay, it's just a general function. N is just any coefficient, a is any exponent, and x is just the variable. Okay, so one thing, Joanna, that you weren't here for is this is how you write derivative. So instead of me writing out the word derivative every time, this is the notation for it. So it's f prime. So whatever the function is, if you have the derivative of it, it's f prime, g prime, whatever that is, okay? So to find the derivative, you're going to multiply a times the n, and then you're still going to have the x power, and then it's going to be a minus 1. Okay? So a times whatever your n, whatever your coefficient is, and then a minus 1. And you subtract 1 every time. All right? Now, how does it work? Who found this pattern? I don't know. I think what it was is way back when mathematicians would do problem after problem after problem to see a pattern, they came up with this pattern. Okay? So it's the power rule for derivatives. And it works every single time. So what's cool about that is it allows us to do some shortcuts, which is really nice because that definition of a derivative gets long and tedious and out of control. And we don't want to deal with it because we want to be able to look at some really cool functions. So, okay, so let's just try some. So I gave you those. And then we're gonna try some with different types of functions. So here we go. So if you had f of x equals 3x to the 4th minus 2x to the 3rd plus 5x to the 2nd minus 3x plus 2. So do you see now we are able to work with much bigger polynomials, much more exotic functions that make, the power rule makes it much easier to work with, okay? All right, so let's just go through one at a time. All right, so Joanna, can you give me the derivative of each piece, or the first piece, sorry. Okay. To the 3rd. Good. Perfect. Okay, Nicholas, how about the next one?
Minus 6x squared.
Okay. And Alan? And Casey? Minus 3. Okay. So here's the question. What happened to our plus 2?
It got canceled out with the difference quotient.
Okay. Okay. So it doesn't get canceled out.
It doesn't have a power next to it, so it's 2 times 0.
Okay, so here we go. That's it, right? If I were to continue on with my descending order, this would be x to the 0 power, 0 times 2, right, is 0. So 0 times anything is 0.
Anything with a zero power is
It is, right? But I'm multiplying. Remember, you're taking the exponent and you're multiplying it by the coefficient, but the exponent is 0, right? Because this is x to the 0 power, which is 1. 1 times 2 is 2, right? So 0 times 2 is 0. 0 times x to the negative 1 is still 0. So that's one explanation. The other explanation is when you have a constant, right? We have a constant. Let's say we have a constant at 2. And we have this line that goes through. So at some point, right, if you think about the graphing of a line, at some point, this graph crosses our y-axis at 2. Okay, at some point. We don't know where. There's going to be, this one I can show you is, it has a shape that looks something like this. And that's just because I know the in behavior and all of that. So at some point it has a value at 2. Okay? So what did we just find here? What actually is this? It's the slope. Okay? So it's the slope. It's really important. It's the slope. Well, look. If I have slope and I'm coming along and it hits a horizontal tangent line, what's the slope of it? 0. I come up here, it crosses at 2. What's the slope right there? It's 0. That's why there's no 0 there, right? There's no slope there. It's a slope of 0. It has a slope. It's a slope of 0 at that particular point. Okay? So that's why whenever you have a constant, your slope is always going to be 0, because that's the point where your graph crosses that y-axis. Okay? So it's going to change there at some point. Okay? So this is a slope. This is not the value of y. So that's why you have to make sure you have this tick mark. It's f prime. It's the derivative of this function. All right? So now if I said what's the slope, or what's the instantaneous rate of change at x equals 1, now I can plug a 1 in here and I can tell you what the slope is right at that value. And then we could actually start graphing it. Okay? So you found the slope. Much easier than the definition of a derivative.
What happens if you do the power rule to the answer?
Like if you do it again?
Yeah, what happens?
Okay, so this is what's cool. That's called the second derivative. Okay, so let's talk about derivatives. Let me give you a scenario. So we have a position function. Okay, I'm driving along. I have a position. When I have a rate of change of my position, do you know what that is? So my rate just changed. My position was here. It went to here. What was the change?
Driving.
So the distance changed, but what else changed?
Time.
Over time. The distance over time. So what is that? Miles per hour. What is that? Speed. It's velocity. That's your first derivative. The first derivative of a position is because you're changing your distance over time. You went from nothing to 60, right? 60 miles an hour. That's your change of position over time. So velocity is your first derivative, okay? So now if we do a second derivative, if we take this again and do a second derivative, now it's the change in speed over time. What do you think that is? So your speed now changed. What happens when you gun it? What is that called? It accelerates, right? When you accelerate, your speed has just changed over time. That's your second derivative. So position is your function. First derivative is velocity. Second derivative is acceleration. So then what happens when you accelerate quickly? What happens to your body? It moves. It gets jerked back, right? It's called a jerk, right? It's when you get jerked back into the seat. That's the third derivative. So derivative isn't, don't think just slope like the slope of a line. Think of how things change over time. Okay, so that position one is a really good one because it's something that you do every day. When you came here, when you sped up, that was your first derivative. When you accelerated, that's your second derivative. When you gunned it, because you were showing off, that's your third derivative. My brother is a huge car buff, and his first car that he ever fixed up, it's a 1966 SS something, but he does it with nitrous. And so his favorite thing is to take people who've never been in it before out in it, and when he guns it, they get slammed up against the seat. It's actually really fun. I let him do it because he's a safe driver. I would probably get thrown or whatever. But anyway, so that's the whole thing around derivatives is we're not going to just take the first derivative. We're going to take the second, third derivative. Okay? All right. So your question of what if it's negative. So let's try one. We have a g function. And let's say I have negative 2x to the negative fourth plus 3x to the negative 1 minus 5x to the second. We'll do it that way. It's the same rule. The power rule for derivatives works the exact same way. Just watch your positives and negatives. So when I drop this to the front and multiply, what do I get? So I get 8x, and when I subtract 1, negative 5. So do you see how it kind of goes in the opposite direction? So you have to be careful. You're always subtracting 1. If you're subtracting 1 from a positive, obviously it's going to go down. But if you're subtracting from a negative, it's still going down. It's just going in the negative direction, okay? So then this one, what does this one become? Good. Oops. And I will still do this. Even though I know in my head what I'm doing, I'll still write it. Negative 4 minus 1 is negative 5. Negative 1 minus 1 is negative 5. And then what's this one? Negative 10. And I'm subtracting off 1. So it's negative 10x. So this is my derivative. Now, be very, very diligent about giving a mark. Identifying what it is. Because if you're just writing just this, right, if you just write that, you're not going to know if that's your first derivative, second derivative, third derivative. You don't know what it is. So make sure you identify what it is.
Would you put a second prime if you were taking like the second derivative?
Yeah, it would be 2 primes, double prime. Yep.
Okay.
Yep, that's exactly what you would do. Good. Okay, so this is the easy stuff, right? Okay, so now we got to review something. Because you know there was a reason why we did this. Do you remember these? First day? How do you change it to a fractional exponent? Okay, so we're going to bring this, and we're going to make it x to the 2/3. Okay, now, if I asked you to find the derivative of this, you can't do it. Power rule doesn't work. But the minute you change it to a fractional exponent, now it works, right? So if this is my f of x equals x to the 2/3, my derivative, you're going to do the exact same thing. I'm going to drop my 2/3 to the front and multiply. And then I'm going to subtract 1. So do you remember when we were subtracting all that stuff? Well, and I said just get used to subtracting 1. Okay? So now what's my exponent? Negative 1/3. Good. Okay, so not too bad, right? You just have to remember, oh, that's right, we got to subtract 1. Got to subtract 1. And you're working with it in terms of a fraction. Now, the first semester I taught this, I made my class go back to the radical. What do you guys think? I was told later, it's all right. They don't need to go back to it.
What's the radical?
Okay, the radical is this, right? So that means this would be written, I'll write it for you, and you can see if you can identify it. What are you saying? That's what it would look like. Okay, 2/3, right? 2 is numerator, 3 is the denominator. This negative says that has to be pushed to the bottom, right? This 1/3 is the same as cube root of x, just like this is the same as cube root of x squared. Okay, it's the same thing, right? So here's what I did last semester. I finally got nice. This right here is a perfect answer. This right here will give you extra credit on the test. Okay, so if you choose to take it to this, it's bonus points.
So is it that you don't want the negative or you don't want the fraction?
Both.
Okay.
Yeah, both.
But what if it,
Okay, here's the question.
Okay.
Here's a question. What if on a test we get that and we make a mistake on the one
On the bonus, then it doesn't count against you. So this is what I'm looking for, right? That's what I'm looking for, but if you can change it, then I'll give you extra credit points for it. Good? Okay. All right, so what we're going to do, I want to make sure that I have everything. Okay, I covered those, covered those, covered those. Okay. I have, where is it? My binder's starting to get too full. All right, so each of you have 12 problems. Do not look at the second page. And we're going to finish with a quiz tonight, but it's a group quiz. So that's why I wanted to do this. Let me turn this off. I wanted to do this individually, and then